In this module, you'll learn all about the Claroty Edge solution. Edge is a dedicated asset detection and asset metadata collection solution. The Edge probe is specifically designed to collect information from surrounding network devices using a Microsoft Windows-based device as a base. This course will familiarize you with the basics of Edge, including what it is and how it works, how to install the Edge probe, and how to operate Edge through the CTD user interface. The Claroty platform is a concept that consists of the three software-based solutions we offer, built on our four main pillars of value, that is, reveal, protect, detect, and connect. In that context, visibility refers to being able to see everything you have in your network. As we know, everything you can't see, you can't protect. Visibility covers things like asset data, network connectivity, network hygiene, the quantity and type of transmissions through your network, numbers of lost packets, traffic volumes, and bandwidth that is used in the network. As far as developing industrial cybersecurity solutions goes, we usually stick pretty strictly to operational technology. But Claroty also monitors market trends and developments, and our support for areas like IoT, industrial IoT, smart buildings, electrical grids, and Industry 4.0 is pretty comprehensive and growing all the time. Each of our customers utilize our products in many different ways by asking themselves, so why do I need this visibility? How can I optimize my processes? And how do I monitor my OT life cycles and make sure they're working in the best ways they can? Which is quite natural. The ultimate point of cybersecurity is to maximize productivity by minimizing instability. As a Claroty representative, one of your major challenges is to master the art of explaining exactly what role each of the different Claroty solutions have within the overall platform, and how different combinations of Claroty solutions can be applied to every customer's issue to get the greatest benefit for the lowest cost. A great way to start understanding how to do this is to ask, from the point of view of a customer, where do I start? How do I use this platform of solutions that Claroty offers? So let's recap on the four different methods used by Claroty solutions to collect data and provide detailed visibility into a network. They are passive detection, active detection, application database or AppDB, and Claroty Edge. Edge is a software-based data probe that gathers detailed information from the asset inventory from the level of the Windows-based host machines that form part of the network. When this information is gathered, Edge relays that information to an upstream CTD site at which data from multiple Edge installations is typically aggregated. Now, let's see what the CTD Edge integration actually looks like within the CTD demo environment and the value it's capable of offering. To do the demo, I'll open the CTD with Edge scenario. Going to my browser, let me point out that I have three demo instances running: CTD, SRA, and a remote desktop on which Edge is busy running. Now, notice that this machine is clean with no data on it. It's also set in training mode. If I open the asset list view, I currently have no hardware assets listed. So if I go to the Risk and Vulnerabilities Insights view, I have no insights either. No assets equal no insights. It's also a little funny to look at in this way, but if I open the Risk and Vulnerabilities overview, my hygiene score will of course be 100%. No assets mean no points of failure. Now I'm going to run Edge within a CTD environment. To run Edge, I need to connect it to this remote desktop, which is a Windows-based machine. Normally, I could do this from my own Windows-based machine, from which I'm running this session, and connect using RDP. However, we don't have a Go link in this demo scenario. The other way I can do it is to connect through SRA, because, as we know, one of the things SRA is designed to do is facilitate remote connections to endpoint devices. So let's do that instead. I'll connect to the SRA central instance and log on as an admin. Note that this is not a site, it's a SAC. The next thing I do is connect to this endpoint machine, which is a Windows-based workstation called Windows. This is the site to which CTD is connected, and it's the site I want to protect by applying Edge. I click Connect. This is the Windows-based engineering workstation that I'm currently remotely connected to using SRA. All these engineering workstations at all of these sites have Edge installed. So, going back to the demo, you can see that I already have the Edge component available on that workstation. So all I need to do is run it. Now remember, when I run it, the asset discovery will be taking place through a remote connection, and it takes a few minutes. At work, that's enough time to have coffee and chat with your colleagues around the office water cooler. When we launch it, Edge shows this screen. It's basically asking me what it wants me to do. Now, I need to decide what I want to capture. In the host discovery section, it asks if I'd like to collect configuration information from the local Edge host, that being the engineering workstation that Edge is currently running on. If I want, I can also immediately add custom attributes to the local host. Also, when Edge asks Identify configured ICS devices, it's asking if you wanted to extract the project files from all connected ICS devices. The next section will deal with local network discovery. What Edge is asking is whether you want to run queries on the engineering workstation's neighboring devices, that is, devices sharing the same broadcast domain. The option is enabled by default. As before, the question now becomes, what devices would you like to discover? You can run a device discovery using IT, OT, and IoT protocol broadcasts. You can run a subnet identification using ICMP, and you can also discover IT, OT, and IoT devices directly. There's an important question to ask here. What's the difference between broadcast discovery and direct discovery? Broadcast discovery is quite similar to something like a ping sweep. Edge sends a broadcast message to all device types that I've ticked here, then listens for basic data that those devices have returned. The great thing is that this process is extremely easy. Edge does the discovery in a granular way, meaning it's been designed to avoid compromising the network's reliability. So I'll leave all the boxes checked to run all those queries. Direct discovery is a bit more comprehensive. Based on what devices were discovered during the broadcast discovery, CTD will initiate a device-specific query for each device type that was discovered. So we could say that the discovery has two phases. Broadcast discovery asks what device types are out there, and direct discovery counts the number of devices of each type. Also, I've said before that these queries are type-specific. So let's say I want to run a Schneider query. That query will only target Schneider machines. It won't run on, for example, Windows-based machines or Rockwell PLCs, because neither of those types are built to handle Schneider queries. Now that I've defined the parameters of the discovery, I can start the next step. Here, CTD asks what I want to do with the data from the discovery. My choice here depends on whether or not I have connectivity between the CTD server and the machine from which the discovery is being run. If I know that the CTD server, wherever it is located, is reachable from the machine running the discovery, I can send the data directly to CTD. If there is no connectivity between this machine and the CTD server, I can save the discovery data file to the machine from which the discovery is being run, then manually upload it to the CTD server. In this case, we know that there is connectivity, so we'll send the file directly to CTD. To do that, I need to enter the IP address of the CTD machine. Next, I need to enter the access credentials for the CTD machine, then verify them. When those credentials are verified, I know the CTD machine is reachable. So now, I'll agree to the license terms and run the query. Now the workstation runs the query. This normally takes around 5 to 10 minutes, depending on the connectivity status of the machine you're using. Before we wait for Edge to complete its work, let's take a quick stop at the visibility overview on our CTD machine. Notice that CTD is completely empty. The asset count is 0 and no assets are listed in any category. There's nothing in this environment because no discovery data has been forwarded to CTD from Edge as yet. So now enough time has passed that Edge should have been able to discover all local assets. So let's look at the results. Remember, a short while ago, I connected to the remote desktop environment using SRA and executed Edge on a virtual machine that was completely empty. The output from that machine has now been sent to the instance of CTD we're currently looking at. So let's see what results Edge has given us. Remember, this machine was completely empty with no asset data at all. Looking at the dashboard, I now have a hygiene score reading and asset information. All these devices would have been identified in around 10 minutes at the very most, even though we haven't been looking at this environment for a lot longer than that. Let me use that time frame to give you a contrast. Imagine telling a customer that they could run Edge, walk away from their terminal for a quick coffee break, and that Edge would have completed its work by the time they got back. Now, compare that with possibly needing to have CTD in training mode for a week or longer. Here in the visibility overview, we can see that we already have a number of assets listed. If I go to the assets list, we'll see the volume of information we can gather just from using Edge and the speed with which we can do it. Now, this chemical plant listing refers to a PLC controlling floor level operations at a chemical plant. This level of detail was gathered in around 10 minutes. We have the full complement of device metadata here with no missing entries. The serial number, the model, the device's risk level, its host name, its virtual zone, and everything else about it. Going to device information, we've captured information on all the PLC's rack slots. Going to risks and vulnerabilities, we can see that Edge has done all of the vulnerability management work for us. Because Edge captures device metadata, it can refer to separate databases, compare attributes, and tell us whether there are any known vulnerabilities associated with a device. Again, Edge identified all these CVEs within a matter of minutes. We've also identified that this PLC has multiple network interfaces. This particular piece of information doesn't necessarily constitute a CVE, but it's an aspect of the device that the customer would definitely want to be aware of. Notice that the threat detection section is empty. Threat detection is not an Edge function. If the customer needs this function, it would be provided by CTD's passive detection. Network analytics is also not covered by Edge, because Edge only targets endpoint devices. Again, passive detection is the function we'd need to cover this. Going to communications, Edge does deliver information on communication policy schemas, so it will show us which devices can communicate with which other devices and using which protocols. Now, this is a Windows-based engineering workstation. Once again, in a matter of minutes, we've captured the OS type, the device model, a notification that this information was collected by Edge, the user who's logged onto the device, the serial number, and all other relevant information. Going to device information, the information collected will be even more extensive. I can see the device's installed programs and look at patches that have been applied. If other devices are physically connected to this device, we'll see that too. Remember, all we've done on this iteration of CTD is run Edge. We have not activated passive detection, active detection, or AppDB. All information we've seen so far has come from Edge alone. Going to risks and vulnerabilities, we can see that this device is communicating with external IP addresses. It also has CVEs and multiple communication interfaces. We've also been able to gather information on program match CVEs as well. This means that one or more programs are installed on this device that have well-known CVEs. This device also has open ports that can be used to communicate with it. Using this information, the customer can make an informed decision about whether they're happy with keeping these ports open or whether they pose a security risk. Either way, they need to be aware of this fact. So what we've seen here is an example of how Edge can contribute a very great deal of network visibility in not a lot of time. You'll notice that the threat detection overview section on the dashboard is rather empty. Again, Edge doesn't capture traffic in real time, so it does not alert on anomalies. Also, notice that events aren't captured either. Again, Edge isn't designed to do that, but passive detection is. Edge is strictly designed to gather and relay device information, so you can't regard it as a strict replacement for any part of CTD. Rather, Edge and passive detection are meant to complement one another. When that happens, you get the benefits of a full and fast deployment, together with a real-time monitoring solution that alerts on the slightest changes throughout the network.